Wow, it is crazy windy out, like super loud, rocking everything, banging the doors around. Wish I had wind turbines up, man. I'd be generating gajillions of watts. Let's go take a look.
Shamrock Creek.
Blustery and windy. Every now and then the gusts are just huge. See if we can get one while we're out here. These ones down here in the kind of center of the property, these big 100-footers, check these out. Well, that just proves our point of getting some turbines up and augmenting solar with wind. Solar in the Northwest is tough because you lose a lot of daylight in the winter and you lose a lot of sunlight just from clouds. You can get your solar can be down 10 to 20% availability. So, you know, you had 5,000 watts of solar panels, you might have days where you're pushing 400 or 500 watts through it is all. The 500 watts we have here now on short, crappy days, you know, we'll be lucky to get 50 to 60 watts through it. So you can't charge much when you got that low of power going. So, you know, you either have tons and tons of solar up here or you have wind augmented. So that's our experiment, is the wind in lieu of having an acre of solar panels. We will do that eventually if we have to, but let's try not to and see if we can do a combination. This is the Victron Energy Phoenix inverter. This is a 1200 watt inverter, which should be plenty for in here. The solar system in here, as well as the wind system in here, will be running 24 volts. So batteries and everything will be at 24 volt. This will convert 24 volt DC into 1200 watts worth of 115 volt AC. On this side, just the AC output. 24 volt DC. It's got a remote switch, so you can remote switch on and off. Ground, as we were talking about earlier, when we grounded the entire cargo container, we'll just take this and strap it right to the cargo container since it's already Earth ground, and then power switch. Here's a design I did. I'll share this with a color version. This is just a printout I made because I kind of laid out how the board would look, where everything would mount, as well as how it would be wired. This, as you can see, is the solar charger controller. This is also a Victron. This is the MPPT 15070, so this will do 150 volts PV, which is how much voltage it will take from the solar panels, and it will handle 70 amps out. Based on the wattage we're doing here in this building, with the PV being around, I think it's 48 volts, we should be pushing around 60 amps, so we'll be just fine with this unit. PV in, this is input from the solar panels. Like I said, that can go up to 150 volts, so you can do a lot of panels in serial. And then this goes to the battery, which will be 24 volts in our system. This unit auto detects that, so once it is connected to the batteries, it determines the battery voltage automatically. It also has, just like the inverter, it has this VE direct connector, which allows all these units to talk to a main controller, which talks to the internet and the controller panel and everything, so you can monitor things remotely as well. This unit also has several different relay outputs and remote control functions. Okay, this guy is a DC to DC converter. Because the batteries are all at 24 volts and nothing runs at 24 volts, you need a DC to DC converter to get back to 12 volts. The output of this will just feed a small fuse box. All the things like lights and cameras. When I move the Dishy Starlink system in here, the router for that I'm using is 12 volt DC. So a lot of things can be wired directly to the solar system via DC. There's no reason to go to AC if you don't have to. If you're already in DC mode from the batteries, stay there. Don't convert and invert back and forth. Do that as little as possible. You can put as many of these in parallel as you need to, so you could hook 3 or 4 of these up if you ended up with a ton of DC. In here, we'll see how that goes. The inverter will handle the AC side, which will run all the DeWalt 12 volt tool chargers. I wish I could keep those in DC mode too, but I have not researched that. This unit's super basic, so you've got an input and an output, and then it does have a remote switch option on it. This unit doesn't do a whole lot other than convert the voltage, so it doesn't really have any remote smarts in it or anything. You can put a voltmeter on the inside and on the input and output of this if you wanted, and feed it into the system if you really wanted to see the voltage on either side of it. This is called the Servo Gx. This is specific to Victron. This is not something you would buy from somebody else. Well, other companies make their own version of it, but this is basically the brains. So this thing has tons and tons of inputs for all their different technologies. Some devices use older CAN bus and different things, and this will handle them all. It has USB ins, it has HDMI outs to feed the monitor. You can hook it to the internet via Ethernet, so this will go directly to the router when it's here and out dishy to the internet. So this basically the brains. This thing will let me monitor the whole system remotely or from my phone or wherever I am and whatever I need to do. Super tiny though, it can go pretty much anywhere. This unit is the display panel for that, which is optional. You don't have to have it, but I kind of wanted it because I think it's cool. There's a mount for it as well. So this little guy plugs right into the HDMI, gets power off the USB, and it's a touchscreen. You can monitor everything and check stuff, so that'll be mounted up here somewhere. These are big giant fuses. These are from Windy Nation. I really like these. Let's pull one out. So there's 100 amp, a couple 60s, and a couple 30s for various different parts of the system. When you're building a solar system, fuse everything. You don't want any connection from one system to another that isn't fused, in case there's a short in that line. Let's pull one of these out and look at them because they're pretty neat. Come to the cover. This is the actual fuse. So in this case, this is a 30 amp. So you can wire it directly into here and here. There's the fuse. Big boy. We have 100. They make this up to 500 amps. So the nice thing about these is you can mount them really easily, and then they are covered, so you are not exposed there, which I love. So there, like I said, there's several of these here. I'm not going to unbox all those because they all look the same. They're just bigger and badder. The system will have 3 of these, which are just on-off switches. These are just a single pull position, right? So it goes on the hot side. This allows you to isolate different systems. So one of these will be between the solar MPPT charger controller and the batteries. So I can shut that off. So I can turn that off, which disconnects the batteries from the solar panels. So if I have to work on anything, or I want to mess with the batteries, or I just need the solar system to shut off and stop charging things, I have a physical switch there. There's also one of these on the charger side where the generator will come in, and there's also one of these on the wind turbine. This thing is super cool. This is a shunt, but it is Victron's smart shunt. So as you can see, you hook one there and one there, so all the energy passes through this guy. And this one here has a VE direct connect, which goes to the servo right here. All shunts should go on the negative side. Do not shunt the positive side. It will work, but it is a lot more dangerous, so you should always put this on the negative side. Another mistake people often make is they'll have a battery connected to the shunt, and then the negative for the solar and all that over here, which is great, but then they might take something else and wire it straight to the battery. If you do that, you're not getting an accurate measurement because everything has to go through this. So you should come out of your negative post directly to this, nothing on the battery but that, and then come from this to a bus, and on that bus is where you hook everything, which is what we will do. So I'm excited to use this thing. It should be pretty cool. Here is fuse panel for DC side. I have one of these in the cargo trailer you've probably seen in other videos. This is a smaller version, but this is the output of the 2412 DC to DC converter. So 24 volts on the battery side, it converts it to 12 volts, which feeds this guy. So 12 volts into here, you have fuse points, and then from here you can go out to your lights, to your camera, I'll feed the router, all those things. Anything that's DC powered to come off of this. Again, you can have as big a one of these as you want. It can't exceed the amperage of the unit itself, but you can have multiples of these. So you could have stacks of these if you had a lot of DC. So there's that guy. So when I was talking about bus bars, this is one of those. Let's take this one out. This is a 4 terminal, so you would come out of the shunt on the negative side directly into this, and then tap all your negatives off that. And then on the positive side output you'll have of the batteries, you'll have one of these as well, a separate one. So the one thing that is not here is the charger, which is what the generator feeds. So we'll have a generator hookup in case we need to run this whole thing off the generator for some reason. all the wind's dead and all the solar's dead and whatever, we will have that option to either charge up the batteries or just run the power. What I'm going to do is I have a Victron charger, which hasn't arrived yet. It should be here next week, so I'll need space for that. So I'll mount one of those up here. That will be 24 volts on one side of that, and then the other side, it's the opposite of the inverter basically. It will have 120 volt of AC coming in from the generator at 20 amps. So if we looked at everything, we covered the charge controller, which is this guy. We covered the charger, which is for the generator, which is not here yet. The inverter right here, which is this guy. The 24 to 12 volt DC converter right here. Here is the Servo box, the smart brains behind it all right there. There's a little panel that we're going to have. And then obviously we do not have, here's the bus bars. Here's those switches, fuses. We do not have the batteries yet. We will be running, on this system, we'll be running 12 volt batteries at 200 amp hours, but we're putting 2 of them in series and then 2 strings in parallel, which will give us 24 volts of 400 amp hours. Obviously the solar panels will go up there. We have a combiner box for the roof. It's not here yet, that needs to come in. And then the plan will be to have dishy connected in here and have all those electronics in here as well eventually. So all of this needs to go on that board that I'm going to put up. The only thing I don't have yet is the wind system, which we're working on. There'll be a turbine outside which hits this controller, which can charge the system as well. That you can have as many of these as you want. So we're going to try one, see how it goes. Like I said, there's a lot of bad reviews on every system out there, so I think we're just going to have to try one, see how it goes, and then add more as we need to. Also, here's that earth ground that we just put in over there into the dirt, the copper rod, which connects to the container wall, and will also connect to the dishy pole. We do plan on penetrating the container up in the top corner there. That's where the solar from the roof, the wiring, and the wind turbine wiring will come in, as well as the dishy pole is now installed on the other side of this wall. So once we move dishy over there, the wiring for that can come into the same penetration. We're not going to do that today. There's no point because we don't have any of that stuff ready. However, I'm going to start putting the electronics on this board, so I want to account for the fact that we'll be coming in up in that corner. Worst case scenario, something changes that we didn't foresee, we'll just move stuff, but we should be good. So I'll probably put solar in just down a little bit so I can put the wind turbine controller in above that because it's smaller, and I'll turn it on its side most likely. So let's get started. Drills need batteries. Because I'm kind of anal, I'm going to get a level to make sure these are all level, because otherwise they'll look dumb. I'm pretty sure if they're not level, all of the electrons fall out the side because of gravity, so got to check the leveling. I'm kidding. $1,200 watt inverter, 24 volt for the 24 volt battery system we're using. I think 1,200 watts for AC in here will be enough. I actually mounted that thing upside down, not that it matters. I don't think all the electrons will pour out the bottom. Only because on the bottom, on what's now the bottom side, is literally just the outlet for the AC side, so we'll just have a plug coming out of that. We're not hardwiring it or anything. The top is where the DC connection goes and the VE direct connection for the monitoring system, so I wanted that more easily accessible. I am swapping the inverter and the DC to DC converter from my drawing because the inverter is really heavy. I want it down low. It's going right into the AC plug, which will be right there anyways, and I'll have a little more space to deal with the fuse panel if I need to change fuses and stuff, so I swapped those. Not that you care, but you know, I'm sharing. I actually dropped that guy down a little bit because if we do need more DC power, because that's a 20 amp, if I do for some reason need more, I'll have to add a second one, so I want to leave room for that just in case. I'm not guessing we will, but never know. Loads of wire. This is the DC shunt. As I talked about previously, this is going to measure amperage. This needs to be as close to the batteries as possible and on the negative side. Don't put it on the positive side. So I'm going to mount it way low down here at the bottom because the batteries will be down under the workbench. So we'll mount it down there and we'll wire it up later. Here's the Servo Gx, which is the smart system. I talked about it earlier. All the devices plug into this. It connects to the internet, all that good stuff, Bluetooth to your phone, whatever you need for managing and monitoring everything. I don't actually have to get to this device once it's wired, so I'm going to actually put it way up high out of the way, and that way all the cables that run to it will be out of the way. The panel that you look at it is remotely extended from this, so I'll move that down lower where it's easier to get to. So I'm going to put in the two bus bars, positive and negative, which will be right above the shunt there, so we can wire backwards from that with the switches and things. So I'm actually going to move the shunt over closer to the container wall because the shunt sits on the negative side, and then I'll put its bus bar above it. I didn't want to put the positive really close to the container wall because it's grounded through our grounding rod, so it'd be really easy to have something short there, or have a wire, so I'm messing with a wire, have it disconnect and hit the side and short out. So we'll put negative closest to the wall and move positive to this side. $100 amps of love. I like these Windy Nations too because they come with a fuse and they come with a spare fuse, which is excellent. Be careful when using a power driver to screw these in, because if you hit this plastic at high enough speed, you just crack it. So here's the 60 amp, goes to the inverter. Okay, 30 amp going to the DC to DC converter. Here's the DC fuse panel. Same one I have in the cargo trailer. It's pretty nice. I don't remember what brand it is. I'll link all this stuff down in the description. The one in the cargo trailer is twice this size. They make one with more fuses, but they're pretty nice. Works pretty good. Okay, let's put in some switches. These are just standard on-off switches. They actually have a little locking key thing, which I don't really need because I'm not trying to secure it, but the ones that were just a knob were back ordered for like months or some ridiculous thing. So I just got the key one, and it's the same. You put it in and turn it, but you actually can lock it if you want, but shouldn't have a need for that. Unlike the shunt, which you always put on the negative side, the switches and fuses go on the positive side. I think you can put fuses on the negative side. I don't know for sure. I assume so. There's probably some safety reason you don't, but the switches go on the positive side, so you know that the positive feed is off. Woo! Windy as fuck. Woo! Good Lord. Alright, back to switches. Okay, I have to show you this because it's hilarious to me, but I have this giant bag of wire ties. Well, I have two. One is massive and isn't funny, it's just big. The other one has this logo on it that's awesome, and they're called Strong Ties, but you have to check this out. I'm going to call this guy Mr. Strong Tie. First I was like, why is there a balloon on there? And then I realized, because I'm an idiot, I realized, no, that's a zip tie that's tied, and he's tough. So, they are good wire ties though. But anyways, strong ties. This is just a little LED voltage display. The DC to DC converter doesn't really have any smarts in it, so I'm going to put this little display on the output of this, just basically on the fuse panel, so I can see the voltage out here whenever I glance at it. This is the same one that we're using in the cargo trailer, and I mounted one of these on the solar-powered Starlink camera experiment that we're doing. That's the same device. Quick run through where we are now. So we got everything mounted, or most everything. As I mentioned, we're missing the charger for the generator. That's still coming, but it'll go right here. The wind turbine controller, at least the first wind turbine we experiment with, will go up here. So we have the charge controller, the battery DC converter, the inverter, all the switches, the bus bars, the shunt, DC fuse box, everything pretty much mounted and ready to wire. So I can start wiring a lot of this together. I do need to order the control cables for the servo, which use VE Direct to talk to all these different devices. So I'll have to do that. once we get Dishy moved to the pole outside here, I'll probably put another board across here at the top, and we'll mount Dishy's controller. We'll move the router out of the cargo trailer and into here. So I'll put the router in here. I'll probably put an external Wi-Fi on the container and run a cable out to that, because it's a giant metal box, so Wi-Fi isn't going to have a lot of fun getting out of it. So we'll probably add that once we get all the power working here. So we are right now. So I'm going to do a little bit of wiring here, and then the next video we do, part 2 of this solar project, should be hopefully putting in either the batteries or the panels, maybe both. The wind turbine will probably be the last phase of this, but look forward to doing that. I'm pretty excited. Thanks for hanging with me. Bye.